Welcome back to Chapter 6 again. Section 4 this time we're going to talk about linear inequalities in one variable. Three topics we're going to hit are graphing subsets of real numbers in a number line, solving the linear inequalities, and of course some applied problems. This will be a short section, so relax. Here's a linear inequality. And I need to check my pen here. Okay, linear inequality. This is what it looks like. Now you can pick three of your favorite numbers for A, B, and C. Just put them in, say 7x plus 19 less than or equal to 28. There. Just put numbers in for A, B, and C. The only thing you can't have is a 0 where the x is. And what you're going to try to do is find out which x's could be inserted into this inequality and still make it a true statement. And the solution set is a set of all the numbers that satisfy that inequality. Not just one, but all of them. Here's one example. We've talked about sets, and this is why we talked about sets. Remember, this is the set builder notation. This says the set of all x such that x is less than 3. Notice in particular that 3 is a boundary. So 3 is very important. Notice though that it doesn't say less than or equal to, because it leaves out the equal part. We put an empty dot where the 3 is instead of a solid dot. And then go back here, and you can actually just test this x and see which numbers might work. So for example, if I test with a, say, check with a 5, and I go over here, is 5 less than 3? No, that doesn't work. So the numbers over here fail the test. Well, I hope it works on the other side. Let's try x equals 1. So I put a 1 in this inequality. 1 less than 3, that's a good one. So we got an empty dot here because it was a strict inequality, no equals, and the numbers to the left are good. The numbers to the right are not solutions for this set. Now, before we go to the next part, we want to clean our slate here. Next one. This looks a little bit different. Set builder notation again. The set of all x such that x is greater than or equal to -1. First of all, there's our boundary point. -1, you can see the boundary point right here. But this time we have an equals as part of our inequality. And so where we have the dot, since it's equals, we put a solid dot there. And then we check to see which side works. Check a 2, for example. 2 greater than or equal to -2. Oops, -1, sorry. Yes, that's true. So we picked the right side. So here's our solid dot, and everything to the right is included in that solution set. Next, we'll clear things again. We've got another one. Now, what's different about this one, the first one we were talking about strict inequalities. We used an empty dot because 3 was not part of the set. In the second one, we had a not strict inequality. We had the equals here, so that gave us a solid dot, and we picked which side to draw the arrow. On this one, when we have boundaries on both sides, that means we're going to have an interval. And again, -1 and 3 are important points. So -1, we have an empty dot here because we don't have equals included. And then at 3, we've got a solid dot because we've got an equals included with this inequality. And everything in between is good. So there is our solution set, a visual representation of what it looks like. Next, I'm going to let you go through this. You can either look at the slides that are on Blackboard, or you can go through these, maybe just hit a pause, do a screenshot, print it out, and go through these one by one. But basically, all these lines, all these comments represent different variations of what we just said on the last slide. I'm not going to go through them all. You can do that. It shows you the set builder notation, the English part, and what it looks like on the number line as a set. Next. By the way, we're over halfway there. How about that? So here's a procedure for solving those, with one important exception. What's that exception? We're going to solve these linear inequalities like we're solving the linear equations, except if you multiply or divide both sides by a negative number, the inequality reverses. Negative number being multiplied or divided on both sides. Of course, we do it on both sides. Negative number, reverse that inequality. So this becomes that. This becomes that. It's as simple as that. Oops. I'm sorry. I need to fix that. Let's start that one again. Kill that, and I'll talk about it again. Okay, to solve inequalities, you're going to solve it the same way as you do solving linear equations, with one exception. As you're solving that linear inequality, if you should need to multiply or divide by a negative number, you're going to reverse the inequality. Negative number, reverse the inequality. So less than becomes greater than. And greater than or equal becomes less than or equal to. Just turn it around like as if it went through a mirror. Next, we're going to look at one in particular. So this gives us some practice. Remember, we treat this, for the most part, as if it were an equal sign. But of course, keep that greater than sign, because that does make a difference. So here we go. Now I'm going to collect the x's maybe on this side. I find it easier to do it that way. So first of all, I'm going to work with the x's. I'm going to subtract 8x here, subtract 8x there. What do I get? I get minus 2x. The minus 12 is still there. I haven't multiplied or divided, so I don't have to concern myself with reversing the inequality. The 8x's give me 0, and I'm left with a 2 on the right-hand side. Next, I've got a negative 12 with the x term, so I need to add 12 to both sides. What do I get now? I've got the negative 2x. Remember, I just added. I didn't multiply or divide. So I still have the greater than. And when I add those two numbers, I get a 14. And last of all, we want to find out what x is, not negative 2x. So I'm going to take that negative 2x divided by negative 2 so I can end up with something that says an x. And I'll take the 14, divide that by negative 2. But notice what I've done. I've divided by a negative number. That means this inequality that I've got right here is going to be reversed. So instead of greater than, it'll be less than. So as soon as you divide by that negative number, this flips. So what do we have now? We've done the flipping of the inequality as we need to. There's our x, that's what we want, and less than -7. So what does that look like? Well, first of all, let's use set builder notation for a little bit of practice. It's a set of all x. This is the solution set. Solution set. Set of all x such that x is a real number. We'll give it a fancy R there. And x is less than -7. Okay, there's set builder notation. What does it look like on the number line? Let's draw a quick number line here, see what we've got. So I'm going to put 0 there, and I need a -7, so I'm going to be careful here, make sure I get that -7 because that's important to us. Let's see, 1, 2, 3, 4, well that's the 5, -5, -6, -7, -8. Okay, -7 is important. What kind of a dot do I put there? Well, there's no equal, so there's no solid dot. So I put an empty dot here. Now, which side do I draw the arrow? Do I draw it this way, or do I draw it this way? Just test. Let's test with 0. Put that 0 less than -7. True or false? Well, I just picked the wrong side because 0 is not less than -7. So it's not this side, it's the other side. So I'm going to draw my arrow to the left instead of to the right. And there's a graphical interpretation of our solution set for that inequality. And you can follow through that. And there's our solution set. And there's the graph. Next. Oh no, you're saying, right? Actually, this isn't a big deal. Remember, you solve it just the way you would an equation, except that you sort of got like something similar to having two equal signs. So let's redraw this. -3 less than 2x plus 1 less than or equal to 3. Okay, now we'll go to work. Now focus on what's in the middle. We want the x's all to be in the middle. Well, so far so good, but we do have this plus 1. So I'm going to need to subtract 1, but with the inequalities having 3 parts, I have to subtract 1 here and subtract 1 there. Just remember, you've got 3 parts, so if you add or subtract, you have to do it in all 3 parts. Now, let's see what we have. We just added a -1. So these inequalities do not change, or at least they do not change yet. On the left-hand side, we've got a -4. In the middle, those ones give us 0. So we've got a 2x in the middle. And that's closer to what we want. And on the right-hand side, we've got a 2. Now, just as with any other equation, we don't care about 2x, we want x. So we'll divide by 2. And since we've got 3 sides, we're going to take -4 divided by 2, 2x divided by 2, and 2 divided by 2. Notice I didn't put the inequality in yet. I look at this and say, okay, what am I dividing by? Am I dividing by a negative number? No. So do I reverse this inequality? No. It's still a less than sign. And over here, it's still a less than or equal sign. Now, what do we have? -2 is less than x. Hooray, we've got the x. And less than or equal to 1. And there's our solution. As a set builder notation look to it, a set of x such that x is a real number. You don't actually have to put this, but I'm putting it in anyway because you might see it in an answer sheet somewhere. X is a real number. -2 is less than x is less than or equal to 1. There's your solution set in set builder notation. What's it look like on the number line? Okay, here's a number line. Now notice what the special numbers are, the border numbers, a -2, so we want to make sure we show -2 on the number line and also the 1. So we'll put the 0 here, 1, 2, 3, 4, 5, and then -1, -2, -3, -4, -5. Okay, so at -2, what kind of a dot do we put? An open dot, because it doesn't have an equals. What kind of a dot do I put a 1? A solid dot, because there's an equals there. And the simple thing is, you can test a number on this side, a number on the middle, a number on this side. What you'll find out though is, it's the numbers in between them. Test it just to be sure. How about the 0? Is -2 less than 0? Yep. Is 0 less than or equal to 1? Yep. You got the right place. And so this one gets you, well, I was going to say a gold star, but a red star will have to do for the time being. All right. And this is how you'd solve it in case you want to go back and check for yourself. And there's your solution set. And folks, guess what? We've actually finished the next section. Section 4 is a wrap. Until section 5, you take care of yourself, and I'll be excited to see you, and bring your questions to class. Remember, just one question, or 2, or 3, or 4, but at least one. See you later.